All right, I've been thinking.
All right, okay. I've been thinking, all right, and I've been hearing a lot of comments on this last video I did. In case you're just joining me, I took that video down, all right, but in the video, the gist of it is that I was saying if we can see a ship reach the horizon, which if you're approximately 6 feet off the ground at the shoreline, the horizon would be around 3 miles away. I was arguing that if we could see a ship reach that horizon and then sail over it, which is supposedly the curve of the globe, my argument was that you should also be able to see an extreme curve from your left side to your right side, because, as I'll show you here, what I was trying to say, I don't think this got across too clearly with some people, but I'm saying if you're in the center here, from a bird's eye view, from you to the horizon in any direction is approximately 3 miles. So what I was saying is that from one side of you, from one, like say the horizon on your right side to the horizon on your left side, that would be 6 miles. And so I was saying if the ship can reach the horizon in front of you, sail over it, in 3 miles, that's some pretty extreme curvature. Like it's quite fast if the ship only goes out 3 miles and then you see it sail over the other side. I mean, we already know that the equation for Earth's curvature is you take 8 inches for every mile squared, so 3 miles out, 3 times 3 is 9, times 8, that's 72 inches. I mean, it's not a lot, but the ship apparently can sail over that. I mean, okay, sure, the ship has to sail past the 3 mile mark in order to start going behind the curvature. Anyway, my point was that from the left side of your horizon to the right side of your horizon, or maybe slightly less, because you can't look at the horizon in front of you from left to right. You actually kind of bring your field of vision in a bit, like I'll show you here, okay? I was just trying to argue that there'd be more curvature there. You should be able to see some curvature on the horizon. All right, now I've heard a lot of people say otherwise, and I've taken into consideration what everyone had to say. There was even a flat earther who told me that this argument was not really a good one, not really winning any battles here on the flat earth front. So I took some time, thought about it, and I think I am beginning to understand what everyone is saying. No big deal, no hard feelings. Okay, so what I mean is, I guess I picture myself, as I tried to look at it from this different perspective, I pictured myself standing on a ball. And let's say this ball is 10 feet in diameter. As you look down, you can see the curvature. You can see that this horizon would be quite low, but it would curve, if, let's say, standing on the center of the ball at the top, as you're looking at the horizon directly in front of you and you're pointing at it with your 2 hands, to trace the horizon out, your hands would go further out away from you, to your left and to your right, and they would start to come behind you because that's the nature of a sphere. You'd see the curve go behind you because you're standing in the top center of the ball. And now here's a little piece of perspective for you. If you actually were to take that ball and expand it, as the ball gets bigger, the horizon would actually come closer up to the real horizon because, as perspective dictates, things that are further away from you appear to be closer to the horizon. Whether it's above you, it appears to be lower, and if it's beneath you, as it moves toward the horizon, it appears to rise up. And so this sphere that you're standing on, say it's 10 feet in diameter, if it were to expand to 100 feet in diameter, now the horizon would be closer to the actual horizon. And I guess what I sort of figure is that if you're staring at the horizon in front of you, and it's not perfectly level with the real horizon, or it's not level with your eyes yet, but as you're staring off at this 100-foot sphere's horizon, in order to trace it, you would, if you would keep your eyes on the horizon. If you just do a perfect circle and turn around and look at the horizon all the way around, you're not going to be looking down per se. How do I explain this? You're not going to be looking further down. So what I was thinking in the last video was that if the Earth is a ball, I should expect to see curvature on the horizon. But I wasn't taking into account the fact that the ball of the Earth would be beneath me, not in front of me like some kind of painting. So I shouldn't be able to look out and see curvature on the horizon because it's not a circle in front of me. It would supposedly be a sphere beneath my feet. And so going along with this standing on a 10-foot ball image, if you expand that ball in size to be, the size of the Earth, or I don't know, however big it would need to be, eventually the horizon of that sphere could potentially rise out to look like a horizon in front of you. And as you look around at this horizon, you just have to spin in a circle and it's going to be flat all the way around, if the ball were that big. As well, we can agree the horizon would be a flat circle around you, but looking at the ground leading up to the horizon, that would be curved. Light would play on it differently if it were curved versus flat. As you can see in these images, light on a flat surface acts completely different than light on a spherical, curved surface. The size of the sphere doesn't change anything because aside from size, all spheres are the same. So there you have it. I mean, I guess I'll say thanks to the guy who, or girl, who commented on my last video and said this isn't helping the flat earth argument. I think you're right. I think that we shouldn't expect to see curvature on the earth when you're just standing on the ground itself. That makes sense to me now. I can see the argument. I can see why you said that. And to everyone else who is a globe earther and who thinks likewise, cool. Okay, so we can agree whether you're on a flat plane or whether you're on a ball earth, the horizon actually would appear to be a flat circle around you. All that being said, I still believe that if you were to rise in elevation, if you were to gain elevation, that horizon that you're looking at from eye level on the shore, as you ascend in elevation, you should be looking further and further down on the horizon, especially if we're on a ball. And it should look lower and lower and lower as you get higher and higher. The fact of the matter is, people have sent weather balloons up to over 100,000 feet, and the horizon still appears to rise to meet the level of the camera. And on a globe, that just wouldn't happen, especially if we know that for every mile squared, the Earth should curve down 8 inches. That's quite significant. And I mean, there's even more proof, like, you know, we got photos from the ISS of Florida taking up like a quarter of the northern hemisphere. So right there, you know, the globe Earth has trouble. I mean, it's always had trouble, but yeah, anyways, all that being said, the reason I deleted the other video was because I was mistaken in my views when I made it. I don't want people coming to my channel and seeing a misconception about flat Earth, thus perpetuating its misrepresentation. Alright, so that's it for now. Thanks for watching. I will see you next time.